I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, August 9th. Tonight we'll be discussing jet stream level winds, surface level pressure, significant wave heights, and all the things that go into making surf in the North Pacific Ocean. Let's get to work. Looking at significant wave heights for the South Pacific Ocean, we see a tiny little gale producing 32-foot seas south of New Zealand over a really small area. Some other seas in the 20 to maybe 24-foot range, aimed pretty well northeast. Another small gale, but all its energy, you can see, is pushing southeast of no interest. And yet another gale producing 34-foot seas, 35-foot seas off of Patagonia, but outside of the Southern California swell window and of no interest to us. All right, let's start getting into the details. As usual, we start looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales. When those gales form, help direct their track. We're looking for a trough right here. That's where the jet stream pushes off to the northeast. That helps set up a clockwise flow in the upper atmosphere and down at the surface, and that is the hallmark of low pressure in the southern hemisphere. And of course, low pressure, if it's strong enough, creates winds. Winds, if they're strong enough, create seas. Seas, if they're high enough, radiate away from the fetch area and turn into swell. And swell, when it hits your beach, eventually, turns into surf. All right, so we do have a little trough being fed by 140, 150 knot winds, so that's not too bad. And we already know there's a gale somewhere right in this vicinity, so this is all sort of playing together, making sense. But then when you get east of there, you notice the jet stream starts falling southeast, pretty much locking everything down over the rest of the Pacific relative to the Hawaii and California swell windows. Right, so let's put this in motion. We see that trough continuing into Monday, and then even into Tuesday, though, turning a little bit more zonal. The winds aren't pushing northeast, they're starting to push more west to east. And that's not so great for directing swell up towards the northern hemisphere. Then by Wednesday, it kind of looks like things start going to sleep. Yeah, there's still a trough here, but it's actually falling southeast. It doesn't have a lot of winds pushing up into it, and no real support for gale development. And then over in the southeast Pacific, you see it's just a zonal pattern. The ice line's at about 63, something like that. So everything is basically getting pushed over Antarctic ice. There you go. Now see, this is still a persistent kind of trough into Thursday night. Friday, not very strong though, not a lot of wind energy. Yeah, it's still there. Weak low pressure in the upper levels of the atmosphere. And then almost looking like another trough wants to get going as we get into Sunday here. Let's see where that goes. Maybe. Ice line is right here. The apex of the trough is about 59. Maybe, just maybe. Hard to say. We'll keep our eyes on. I mean, the models have been kind of doing this teasing thing, and then the closer you get to it at the time whatever gale's supposed to form, it ends up not being a whole lot of anything. All right, let's go take a look down at surface level pressure and surface level winds. And as expected, here's our little gale. Look at the size of that fetch area. That's tiny. So between 10 degrees, it's north-south, and down this far, that's not even 600 nautical miles. That's probably about 200 or 300 nautical miles. That's probably about as much fetch as there is in the California gradient in the summer. All right, but anyway, you get the idea. A little bit of fetch. It's supposed to push east and really weaken by Sunday night. Still a broad area, 30, 35 knot winds. I mean, this is good for Tahiti, but for Hawaii, maybe, probably not. Okay, another gale or another fetch associated with this gale come Monday night. 40 knot winds, but you look at the arrows, they're almost aimed southeast. Little bit of fetch, maybe. We'll keep our eyes on that when we get into the wave models. 30 knot winds. See, that's aimed good. All looks great, but that's not strong enough. There's your 45 to 50 knot winds, but they're all aimed due south over Antarctic ice. Penguin storm for sure. Nothing for us. And then everything falls apart as we get into Thursday. Another one of these weak 30, 35 knot fetch kind of things. There we go, 40-knot winds as we get into Friday. We know there's a gale or a bit of a trough trying to develop there. Doesn't really do a whole lot. I mean, we'll see what the wave models say. As we get into Saturday, again, they all just start crashing southeast. And, oh, now look at that. Cutoff low. I didn't even notice that. Supposedly. Cutoff low developing Saturday. Now, typically, these things don't do as good as what the models say. But was that 30, 35 knot winds? You know, this is probably good for Hawaii to build a little bit of swell because it's so far to the north. And certainly for Tahiti. Where's Tahiti? Like somewhere right in this vicinity. 23 south. Somewhere in there. So, yes, sideband. Oh, look at that. 40, 45 knot winds. If this happens, it'll be a miracle. But something to keep our eyes on. And then another little fetch under New Zealand. So, looking at all this, I mean, there's little bits of hope, but nothing solid, nothing that we're getting excited about. But let's go see what the wave models say. We're just trying to second guess the wave models here. Right, so we're going back in time. This is Sunday a week ago. Little bit of a gale developed in the far southeast Pacific with 31-foot seas, lifting northeast in the Southern California swell window, and then it faded out Sunday night. Swell supposedly is in the water and supposed to arrive in Southern California right about now, you know, tiny, like 1 foot at 20 seconds. But as we get into Monday, Tuesday, Wednesday, there should be rideable surf and exposed breaks in southern, central, and up into Northern California. We'll see how accurate the models are regarding that. All right, and then we went in, now we're at Tuesday of last week. We're just sort of looking for anything else that might have happened since the last video. You see the pattern, all west-east, the ice line, 62 south, 63 south. I mean, it's pretty, it's, you know, just past the peak of winter down there. Don't expect a whole lot. Now, there's a little gale, but it's out of the California swell. Oops, look at that, actually. No, probably nothing to come from that. All right, another little gale formed. Here we go. We'll go back to Saturday morning. This is yesterday. Small, tiny little gale under New Zealand. 33.1 foot seas. Aimed a little bit off to the northeast. And then this morning it died. And then it tried to reorganize. Here's current time right now. Now let's go look at the forecast. All right, and this gale pushes east and pretty much is gone by tomorrow morning. Broad area of 20, 22, 20, we'll say 24-foot seas. Oh, another little pulse of 30-foot seas on Tuesday. Not over a large area, but you know what? At this point, anything is good news. We'll take it. There'll be some little, you know, waist-high swell or something, maybe chest-high at top spots in Southern California. And that all fades. We're into Thursday, Friday. Another little gale tries to organize under New Zealand. On Friday, 30-foot seas. We'll see if this happens. And it pretty much vaporizes. I mean, where is our storms with 40-foot seas? You know, that's what makes real swell. I mean, 30-foot over a decent-sized area will do it if it's aimed well to the northeast, but we're not seeing any of that. And then here's that cutoff gale. Here, we'll move off to the side here. Actually, 32-foot seas there. We'll go one more. Yeah, 30-foot seas aimed north. If this happens, I mean, this is a week out. Don't believe it. And it's cut off, so that always, it seems like the model overestimates it, but we'll see. That is, the good news is, this one is well off to the north, aimed well to the north. Hawaii could get some decent swell out of that if it were to happen. So at least there's something to look forward to. So aside from southern hemiswell, well, the wind swell thing has been a blessing in Northern California. High pressure in control of the Gulf of Alaska. Notice there's actually 35-knot winds supposedly in the Gulf of Alaska. We should go look at the wave model here for a second. So here we are, what is that, 23-foot seas, 23.9-foot seas, almost not even in the Northern California swell window, pushing into Alaska, and that's it. We'll just run this out. So the wave models are talking about some sort of a tropical system here too, pushing off of Baja and pretty much vaporizing. Can't imagine why that is. When we get into the MJO forecast, you'll see why. More tropical systems supposedly. Don't ever believe the wave model a week out. And we're just sort of scouring the Gulf of Alaska looking. Well, you know, if that thing actually forms and it's pushing way to the north, there's some hope there. But again, odds are exceedingly low at this early point in time. All right, so back to where we came from. High pressure, name of the game, typical this time of year, but also with a developing La Nina, or we suspect it's La Nina, then the high pressure tends to get amplified in the Gulf of Alaska, which then amplifies this gradient. That high pressure pushing into the coast, heat low inland, creates a difference in pressure between the two as they get closer, creates wind. You can see it there, 30, 35 knots. There was decent wind swell in Northern California today and yesterday and even Friday, you know, in the head high, maybe a foot or two overhead at top spots on the biggest sets, right on the peak. Of course, the bars are a mess. It's all closed out and that sort of thing. But either way, wind swell, that's when you have no southern hemiswell. Wind swell is okay. So as we get into Monday, 30-knot north winds to continue off of Northern California. Still wind swell. And notice this eddy flow, light winds along the coast here. So you get the low here. I mean, the high here and the gradient, but you have low pressure here rotating, what's that, counterclockwise off the coast. And so that sends south winds along the central and North California coast. Most of this not reaching into Southern California because the gradient's off of Cape Mendocino. If it was down here in Central California, there's better odds for wind swell getting into Southern California. So this is mainly a Northern California, Central California type wind swell pattern. Here comes that tropical system supposedly on Wednesday. The gradient dies out and the tropical system fades too. Should be looking at Hawaii here too for easterly wind swell. Some degree of that forecast. The gradient tries to kind of wake up on Friday a little bit. I mean, just anything to produce some wind swell. But even that, not looking so good. Here, we'll go down. There's supposedly another tropical system down here aimed at Hawaii as we get into, this is OS 6Z Sunday, and then more as we get into 18 and 0Z Monday, and that's a week out from now. The wind swell supposedly dies in California, wind swell dies for Hawaii, and the tropics try to come alive. That said, the Atlantic is really where all the action is going to be, and we'll talk about that in a little bit too. Quick look at precipitation potential for the Sierra in the afternoon. Here we are Sunday night. Nothing on Sunday. Monday, maybe a little bit. You just see a couple little dabs of precip there. That's as much of a hint as you get for precip. And then again, maybe, that was Tuesday. And then everything dries up after that. We're just keeping our eyes right around in here. And we're not seeing anything projected. We're 180 hours out. So what was that, Monday night or Tuesday? Here, we'll just go look real quick again. Right there. It's Monday afternoon is your best shot, and also Tuesday afternoon. There we go, Tuesday afternoon, and then things dry up. Okay, now we're looking at the snow forecast dashboard, but what we're really trying to assess is where is the freezing line at on the Pacific Crest Trail where it crosses Tioga Pass Road. Clearly no snow. Freezing level, well, this is literally, I think it's about 8,800 feet where the PCT crosses Tioga Pass Road, and so red is above 34.6 degrees. Even here, the gray is sleet, 34. It's right around 34.6 degrees, but not 32 degrees. So basically, the freeze line is above 14,000 feet for the next week. No chance of snow. If you get rain, I mean, yeah, maybe you could get some hail, but for the most part, pretty dry and pretty warm. All right, let's go take a look long term. What's going on with the Madden-Julian Oscillation and El Nino or La Nina? All right, so we'll start off looking at winds across the Equatorial Pacific. This is the East Pacific here, West Pacific here. That's New Guinea. 0, that's the equator. Dateline, the international dateline, right about there. This is data from the TAO buoy array, a series of buoys strung across the equator used for monitoring El Nino, but there's wind sensors on these buoys. They don't collect hourly wind. It's more like it's 5-day average data, but you get a good idea what's going on. We're really interested in what's happening in what we call the Kelvin wave generation area, the West Pacific, from 170 west, 5 degrees north and south of the equator, off to about 135 east, right in here. When you get the active phase of the MJO moving over this area, it tends to dampen trades, if not out and out reverse them. And when that happens, that can take warm water that's in this area, start pushing it off to the east, not on the surface, but under the equator, in the form of what they call a Kelvin wave, a bubble of warm water. Travels east, takes about 3 months to reach the Galapagos and Ecuador, and then it impacts the coast there. If it has enough velocity, creates a warm pool on the ocean surface. If you get successive Kelvin waves driven by the active phase of the MJO, they can kick off El Nino. Of course, the reverse is also true. When trades are stronger than normal and the active phase of the MJO is asleep and stays asleep for months at a time, like kind of where we're at right now, and it doesn't produce Kelvin waves even when it does show up and doesn't produce westerly anomalies, then what you get is upwelling over here. So these are actual water temperatures. And the arrows, let's start with the arrows. The arrows are what we're interested in. Wind speeds or relative winds. You see long arrows, strong easterly trades over the East Pacific, Central Pacific, and in the all-important Kelvin wave generation area, trades much stronger than normal. At least it appears that way. But let's look at anomalies. Differences from normal for this time of year. So you look at the arrows here, you see a little bit out of the east, so that means they're a little bit stronger than normal, little bit more stronger than normal over the Central Pacific, and pretty strong as we get into the Kelvin wave generation area. So this is what typically things look like during the inactive phase of the MJO. And if the inactive phase of the MJO, if there's more of them on average and they last longer than normal, that's typically what kind of kicks off La Nina, and that's kind of what's been happening this year. All right, what's the forecast in terms of this trade wind thing? Stronger trades or weaker trades? All right, so what's this chart? It's the whole planet on one chart. The date line, 180 west, runs right up the middle of the chart. Okay, the Pacific Ocean runs from about 135 east to about 80 west, so somewhere right around there. So but from there to there. But the Kelvin wave generation area, that's what we're mostly interested in, because when you get west winds in the Kelvin wave generation area, that helps not only create Kelvin waves, it also imparts energy to the jet stream, feeds the storm track, and helps create, swell and storms. Both in the southern hemisphere, they're not as tightly coupled, but certainly in the northern hemisphere in the winter. All right, so right here is the west boundary of the Kelvin wave generation area. East boundary is right there. So we just go right up the chart and look. So this is past history, July, August. The blues, east anomalies. The purples, very strong east anomalies. You can see we're just wrapping up basically an easterly wind burst. Strong trades. This is typically a sign of the inactive phase of the MJO. The good news is the forecast suggests trades dying in the Kelvin wave generation area. This is over the next week, next 7 days. And westerly anomalies taking over most of the Pacific and even trying to get into the Kelvin wave generation area a little bit. So that sort of suggests that maybe the active phase of the MJO is going to start nosing in. You get the sense that it's hanging over here in the Indian Ocean, trying to bridge the gap here, but there's just this impenetrable wall of east anomalies. Not very strong, but still there. We'll see how this plays out. All right, so let's go out a little bit further. This is a 2-week model. This is outgoing long wave radiation. Fancy words for sunlight reflectivity off the ocean surface. South America, Central America, Australia, New Guinea, Philippines, the equator right there. Okay, Kelvin wave generation areas. This area right here. The blues are negative anomalies. Less sunlight reflectivity off the ocean surface. That means clouds. That means the active phase of the MJO. It looks like the active phase of the MJO, according to the statistic model, is building over the Kelvin wave generation area. Hooray! Finally! And it's to continue 5 days from now. Continue till 10 days, and then fade out 15 days from now. Now that's the statistic model. The dynamic model is again corrupt. I don't know what's going on here. I mean, I guess at some point we'll write no and say, hey, your model's not working right. But we've got another way to look at that. Phase diagram charts. This is the statistic model. This is the dynamic model. What are we looking at? Assume you're looking down on the North Pole. It's right here. You're looking down on it. And the MJO, both active and inactive phase, rotate around the equator from west to east, from the Indian Ocean, over the Maritime Continent, over the West Pacific, East Pacific, under the United States, across the Atlantic, over North Africa, back to the Indian Ocean. So the heavy dot here is where the active phase is right now. The further it is away from the circle, the stronger it is. So the active phase is over the Maritime Continent, let's like Bali, and forecast over the next 2 weeks to move into the West Pacific, but crash and get progressively weaker. Okay, that's per the statistic model. The dynamic model says pretty much the same thing, but it moving even faster, like twice as fast, and it's over North Africa 2 weeks from now. So there's really only 1, 2, 3, 4, 5, maybe 6, maybe a week's worth of potential for the active phase to do anything, supposedly, in the West Pacific in terms of imparting energy to the jet stream and, feeding the storm track and all that kind of stuff. So, a little bit of difference between the two models here. Let's keep going. Here's the upper level model. This is used to determine potential for precipitation. The green's favorable for precipitation, the yellow's not favorable. That roughly equates to yellow's inactive phase, green's active phase. We want to see a robust green pattern, and we're not seeing it. The good news is we see the inactive phase pushing out of the Pacific and into the Atlantic. That's good news for us. But here's our supposed active phase. It was stronger a couple of days ago, and now it's just literally supposed to vaporize as it moves into the West Pacific. Oh, yeah, can you read this? Okay, so top chart here. There's the equator right there. South America, Central America, New Guinea, the date line's roughly there. So the Kelvin wave generation area is right there. And it's just the same panel every 5 days, so you can sort of see active phase. You can just see it move across the Pacific and into Central America by mid-September, something like that, and then a weak inactive phase is to follow. So no real obvious signs. The active phase is what would support storm formation. No real clear signal of that here. So then we go to the CFS model. It goes out 1 month. So this is showing some good news, but it's kind of like mixed signals here. All right, so what are we looking at? Whole planet on one chart. Kelvin wave generation area. Fancy words for the far West Pacific from here to here. That's the area we're interested in. The heavy, dark, continuous line is the active phase of the MJO. And here's the dates over here. So you see the active phase of the MJO is in the Kelvin wave generation area right now. Forecast to traverse it through about August 22nd. So we got about 2 weeks where the active phase is over the Kelvin wave generation area. Now, here's the interesting part. Look at this. See the blues? That's easterly anomalies. We have westerly anomalies as the Kelvin wave generation area as the active phase of the MJO starts moving into the Kelvin wave generation area. Then east anomalies prevail, and then west anomalies finally take over, but only after the active phase of the MJO is out of the Kelvin wave generation area, and after it, once it's over here, it doesn't do anything for supporting the jet stream or anything like that. Yeah, it helped feed tropical development. All right, so what is going on? Well, let's keep going. And then you see blues, easterly anomalies continuing, and then the inactive phase sets up in the far West Pacific about September 5th at the end of the model run. So what's going on here? Well, we have this red thing. What's that all about? That's another Equatorial Rossby wave. So that has some effect, and you can kind of see it appears to be interacting. That is interacting with this purple thing. And what's the purple thing? Well, you all that have been around, low pressure, it's a bias. It's the low bias, low pressure bias, but when it's dotted, it's opposite. So this is really a high pressure bias, and that's sort of this. So there's a high pressure bias locked over the Kelvin wave generation area. That's typically what happens when you get La Nina. Then you get an equatorial Rossby wave that amplifies that. And so even when you have the active phase of the MJO. This is 3 different waves, atmospheric waves, interacting at the same time. And at the end of the day, the high pressure bias and easterly anomalies prevail, even though we have a decent active phase of the MJO. And you can see it in the far West Pacific maritime continent. And again, when it gets into the Central and East Pacific, but over the Kelvin wave generation area where we need it desperately to do something to feed the jet stream, it just gets stomped on and then it dissipates and easterly anomalies continue, and then the inactive phase of the MJO comes and probably is only just going to feed those easterly anomalies only more. All this smells very much of La Nina. And then finally, this is the 3-month CFS model, focus on MJO and ENSO, the El Nino Southern Oscillation. Right, same deal here. West Pacific starts at 135 east, and the Kelvin wave generation area goes to 170 west. The far East Pacific, Ecuador, over here at 60 west. Now, it's reversed, though. This is past performance here, and you just see a nice shading of blue filling the Pacific. I'm being completely sarcastic there. I wish it was all yellow and red. And what do we see looking forward? Continued nice shadings of blue, if not building into this time. And then even beyond, the balance is still blue, though there's at least a little hint of westerly anomalies. All right, so if I were eyeballing this, I'd say that's inactive phase, the MJO. This is probably active right here, and this is probably some flavor of active here. Let's overlay the MJO, see if we're right. All right, here we go. Solid red contour, active phase of the MJO from now till about, in the Kelvin wave generation area, till end of August, something like that. So if there's any hope for storm production in the near-term future, this is it for the next couple of weeks. And then, boom, inactive phase sets up. Pretty robust one, too. 1, 2, 3, almost 4 contour lines, where this is a 2 contour line active phase. So this would be twice as strong, theoretically, as that as the active phase, which is so wimpy. Strong easterly anomalies projected, but then 1, 2, 3, 4, 5 contour active phase of the MJO to set up moving into the Kelvin wave generation area. September 10th into early October. This might be a pretty decent window here to like kick fall off, maybe get some storms. So I would say be available for surf, but don't hold your breath for the next 2 weeks. Then sort of do whatever business you have to do. Then as we get into September, the whole month, for almost a month there, it looks like there's a window. Then after this, the picture has been very mixed, but inactive phase and then active phase. The good news here, look at how weak the MJO was here pretty much all year. It's just been non-existent. The good news is the MJO is finally supposed to wake up. So at least when you get the active phases, they'll have some energy. Maybe they'll do, push something into the jet stream and we'll get some storms. So that's a better place than where we were for almost the past year. So I'll take it. All right, but low pass filter. Now this tells the other side of the story. The dotted contour, the dreaded high pressure bias. We had the low pressure bias in the Pacific last year. Now the high pressure bias has taken over. All this just says this is the typical La Nina thing. All the energy, the low pressure bias that was here last year and years before that has moved into the Indian Ocean. The Indian Ocean is where all the storm activity is, and we're left high and dry. We're praying that these supposed stronger active phases actually give us something. And during La Nina, that doesn't mean there is no surf. What it means is the odds for big storms are much less. The number of storm days or swell days you get from the storms that do happen are fewer. The size of those waves typically are less. And, because all the energies in the Indian Ocean are in the South Atlantic. So that's kind of what it looks like we're at, given all the models so far. So then we start moving to the El Nino part of this. We're done with the MJO bit. Let's go look for the presence of either El Nino or La Nina. First stop, subsurface ocean temperatures. Again, TAO buoy array, West Pacific here, East Pacific here. These are the anchor lines on the TAO buoys. The X's are the sensors on those anchor lines. The sensors collect water temperature data subsurface and give us a profile of what's going on in the ocean. Where is the hot water? Where's the cold water? Typically during El Nino, the warm water, this is 29 degrees centigrade, starts moving off to the east in the form of Kelvin waves, and you start getting warm water building here. The reverse is true. When the trades are strong and nuking, you get upwelling in the East Pacific, and then this is called the thermocline. The lines that demark where water areas of common water temperature are. The thermocline gets steeper from here, going up like this, instead of when warm water here, it's more flat across the Pacific. All right, so 29 degree isotherm, it's about where it was last week. Was at about 165 west. 28 degree isotherm, it's been hovering between 160, 165 for months now. No different here. 24 degree isotherm, at times it's made ventures into Ecuador, but it's sort of backtracking now at 121 west. And otherwise, cooler water. But that's just the situation, not looking at, it looks like it's colder over here. Let's go see. Anomalies, differences from normal for this time of year. All right, so whatever warm water you got, we want to see balls of warm water moving from west to east down about 150 meters. That would be a Kelvin wave, but I'm not seeing that. What we're seeing here is cool water, in fact, 3 degrees below normal, traveling from west to east, and also upwelling to the surface in the mid-Pacific. Where is that exactly? From 160 west to about 135. So south and east of Hawaii. Oops, there we go. Okay, and a one little lingering pocket of 0 degree anomalies. It really looks like this guy is a cold water Kelvin wave. He's going to go off to the east, wipe out everything, and you're just going to get this big cold signal. In addition to that, there's a pipeline open here for cool water. You can see it just flowing from west to east through here. I mean, this all subsurface-wise smells very much like La Nina. Here's another model using the same data. It's painting the same picture, maybe even worse. More cold water. There was warm water over here in the other model. This one's all cold water tucked up along Ecuador. The cool pool, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yeah, we'll say 3 degrees, maybe 3.5 degrees below normal in its core. But then there's another pocket building here coming off of, where would that be? Somewhere in the far west Pacific coming in. So it's basically 1, 2, 3 pockets, 3 cold water pockets traveling off to the east. Instead of warm water traveling west-east, it's cold water. So cold water Kelvin waves, if you will. That's a typical La Nina sign. Sea level anomalies. So this isn't temperature data. This is the height of the ocean surface. Okay, and how's that all work? Well, okay, cold water at depth contracts. If it contracts, the surface of the ocean above it sort of forms a divot. Likewise, if you have warm water at depth, it expands and you get a bulge on the ocean surface. Not a lot. We're talking a couple of centimeters. All right, so what is this showing us? -5 centimeter, -10 centimeters. This is South America, Peru, Panama, Central America. This is the equator here. Here's the date line. New Guinea right there. So what we see is basically cold water doing this sort of thing at subsurface, not at the surface, below the surface. Again, just some validating what the other models are saying, that cold water at depth is in control. Now, the interesting part is it was a lot colder here along Chile and Peru and Ecuador a couple of weeks ago. It's kind of mellowed out a little bit. I mean, it's still cold. There's no warm water, but it's not as intense as it was a bit ago. Let's put things in historical sense here. What is this? Upper ocean heat anomalies. By upper ocean, they mean the upper 300 meters of the ocean. West Pacific here, East Pacific here. Time. The reds and oranges are warmer than normal temperatures. The blues colder than normal. So, Kelvin wave. This was back September a year ago. Driven by the active phase of the MJO in the West Pacific, creating west winds, taking the warm water here, pushing it off to the east. Made it the whole way to Ecuador. Okay, another Kelvin wave, halfway tried to get going. Weak active phase of the MJO. It kind of stalled. Then a second active phase of the MJO gave it a little bit more energy, pushed it east. But then we got into, what was that, April? Upwelling events started. East trade started building as the high-pressure bias set up over the Central Pacific. Major upwelling event here in the East Pacific and the Central Pacific. A little bit of a break, but here you go. We know we've had strong east anomalies for 2 weeks now, and we know there's I'll call it a cold water Kelvin wave, whatever you want to call it, under the Central Pacific. It's trying to leach its way to the surface too. So whatever goodness this was, we're in the exact opposite pattern now. And you also see warm water starting to build in the West Pacific. But once you get into a La Nina, it takes like 2 years of easterly anomalies before the warm water and the ocean levels also build over here, because you have east trades just continuously stressing the ocean surface, pushing water to the east. It all builds up here, and then at some point when it just can't take it anymore and the atmosphere can't sustain the easterly winds, one little blip of the easterly, one active phase of the MJO reverses the trades, and boom, all the warm water starts flowing off to the east, and then we move back into like an El Nino type cycle. Right now, though, we're just at the very beginning of this easterly enhanced trade wind cycle, which is effectively La Nina. All right, so then, what do we have on the ocean surface? This is sea surface temperature anomalies, differences from normal for this time of year. South America here, Central America, you can kind of get it. The blues, colder than normal temperatures. We have cold. No, this is no surprise, right? We saw this last week. Colder than normal temperatures off of Peru and what is that? Ecuador. The difference from last week is the cold temperatures in the Central Pacific are building. This is much stronger than it was last week. We know why. We know there's cold water depth here. We know it's getting sucked up to the surface. We know trades have just been nuking in this area stronger than normal. So no surprise we have a major upwelling event. And this is looking more like the traditional La Nina type signal where you have cold water the whole way across the Pacific. Here's the 7-day trend. We're just looking at the equator here. The blues are temperatures trending colder. The reds, temperatures trending warmer. You can see it right here on the equator. There's South America, Ecuador there, Galapagos there. Colder than water normal building or trending colder off of Ecuador the whole way across the Pacific, almost to the date line. Yeah, there's some interspersed warming areas, but generally a cooling trend across the entire Equatorial Pacific. That does nothing to help support storm development. So here is just the overview of what's going on. You can see colder than normal water. Ecuador there. Equator right along here. All from the date line the whole way to Ecuador, colder than normal water. Little bits of warming here, but that's probably going to get cold out as trades continue in this area. So trades are supposed to back off a little bit, as the active phase moves over the MJO. So maybe that'll prevent this from building too strong. But this clearly, when you have cold water, what that does is it stomps on evaporation. You don't get evaporation. And then and if you want low pressure systems, you need evaporation. Rising energy creates lower pressure. Falling air creates high pressure. Colder than normal water creates falling air. You end up with high pressure stronger than normal here. High pressure stronger than normal here. And as you get into winter, the last thing you want is impenetrable high pressure in the Gulf of Alaska, because any storms that push off of Russia and Siberia get deflecting up into the Bering Sea, and then they get no traction on the ocean surface, and you get no storm development or no winds to produce swells. Sea surface temperature trends in the Nino 1.2 area. Where's that? That's right there, the Galapagos, Ecuador, down into Peru. You can see the trend since May has been downward. Today, our value is -2 degrees centigrade, 2.087 below normal. That's pretty cold, but that's not the official El Nino monitoring region, but we use this for sort of getting a gauge on what's going on in terms of California precipitation for the coming winter. This does not look good for precipitation. If anything, it suggests a very dry winter. The Nino 3.4 region, this is the official El Nino monitoring region, so it was cooler. The scale's different here. Today, it's 0.445, so not even half a degree below normal, which is good. But that said, it too is trending downwards. It was cold. We got a little bit of a almost normal period. Now we're back down, so that's not so good. So what's going on in the atmosphere above the ocean? I mean, you see all this cold water and you go, oh man, things must be pretty miserable. Let's see if the atmosphere thinks we're in La Nina. All right, the Southern Oscillation Index, difference in pressure between Tahiti and Darwin, Australia. When Tahiti has lower than normal pressure, the index goes negatives. Today's value, and they do this, they measure it every day, 8.92. So it's positive, meaning pressure is higher over Tahiti, but not horribly, but look where it was a couple days ago, 25.73. Looking back, well, I mean, it's sort of a mixed bag, but just eyeballing this, I'd say on average, it's been more positive than negative. 30-day average, this is sort of filters all that out. Today's value, 4.47. And where has it been? Well, we were at -2 a month ago. Now we're at plus 4.47. But this varies significantly based on the active-inactive phase of the MJO cycle, but this looks like inactive phase. The 90-day average is the El Nino La Nina indicator today, -0.07. So that's about dead neutral. Where were we a month ago? -1.26. So we're just neutral according to this thing, but this is a lagging indicator for sure. It takes a bunch of stuff and a bunch of energy it takes 90 days for this to reflect what's happening today for the most part. So we're neutral as of right now. I bet we're going to be positive 1 or 2, but that's not too bad. I mean, a month from now, when this gets up to +10, +12, then you're really in La Nina. But you're not going to know it from this until you're already there. So we look at this, but more as a sense of what has happened recently, not for what's to come. 30-day moving SOI. Okay, this is the 30-day average we were looking at, but it's just graphed out so you can look for trends. So back 2018, we were kind of neutral. And then last year, we kind of looked like, we thought we were moving towards El Nino because we were in the negative territory here. You can see these big downward spikes, the active phases of the MJO. But then since October of last year, we've been on a steady upward trend, moving towards positive territory. And I think we're going to continue on that as we get deeper into fall. Now, will we get into La Nina territory up here? Maybe. Hard to say. We'll look at the models here in 2 seconds. But before we do that, one quick note about the Atlantic hurricane season. All right, sea surface temperatures are above normal in just about the whole way across what they call the main development region, the area where hurricanes form off of Africa, the Azores, not the Azores, the Cape Verde storm corridor. There we go. Anyway, when the active phase of the MJO moves over the Atlantic, that helps feed storm development. When you have this, when the low pressure bias is not in the Pacific, but it moves to the Indian Ocean, it shuts down the shear upper level winds over the Atlantic, and that makes it a lot easier for a hurricane to form because it takes height, and if shear rips the tops off of hurricanes, but when you have no shear, then storms can organize. If you have warmer than normal temperature, sea surface temperatures, you get a lot more evaporation. That feeds storms. And then you get the active phase of the MJO moving over that area. And it just is like throwing a match on, dry tinder. It can really help support tropical storm formation. So looking at this somewhere in this late August, early September, pretty good window for hurricane development there in the Atlantic. And then again in the early October time frame. All the official sources have updated their hurricane forecast for the Atlantic, and they're all considered very active. And then these windows right here, we're going to watch very closely to see if they trigger strong storm formation because all the other indicators suggest the Atlantic is primed for a very active year. And then finally, sea surface temperature forecast for the Nino 3.4 region. That's that region in the central Pacific on the equator. All right, so the solid line is what actually has happened, and this is suggesting last winter, temperatures were above normal, almost in minimal El Nino territory. But then as we got into April, temperatures crashed. They turned neutral. Supposedly, in July, temperatures were falling, but we don't see any evidence of that. It didn't really start getting cold in earnest in the Nino 3.4 region till maybe 2 weeks ago, something like that, a week ago. So this is a little overly optimistic here. Anyway, this model continues to suggest temperatures by October 1.1 degrees below normal and staying there into December, and then dying and going to neutral by April. This is actually the second year that we've had colder than normal temperatures in the Pacific. The question is, how cold is it going to get? This is probably, one of the more worst case scenarios, 1 degree below normal. That'd be a pretty solid El Nino. Other models suggesting a pretty solid La Nina. Others are suggesting temperatures at 0.7, 0.75 of a degree, so a weaker, more moderate La Nina. I suspect that's probably the case. This model seems to be overstating it consistently. We'll see. We'll monitor it. But either way, there's no hope. Literally zero hope for any El Nino. At this point, there's even zero hope for a neutral year. We're going to get some flavor of La Nina this winter. The question is just how strong, how much. Probably a modest to moderate La Nina. So the good news, there's a little southern hemi swell supposedly starting to arrive now. We'll continue for the next couple of days to make the most of that. After that, a couple of other very, very weak systems forecasts under New Zealand. Maybe some tiny swell, most of it probably more for Hawaii, and Tahiti probably getting the bulk of even that. Wind swell, copious wind swell. We did see a gale up in the northern Gulf, so some sense of fall is trying to get going in the North Pacific, but it's very early. And even when it does happen with the MJO, pretty weak at least as of right now, it'll probably be a very delayed start to the season. Though we do see some pretty strong active phases, the MJO forecast as we get later into late September, October, that sort of thing. So hopefully a better pattern coming, but we're not holding our breath. I think most of this winter is going to be a write-off. That's not to say there won't be waves. That's it for this week. We'll do this again next week. If you enjoyed the video, give us a thumbs up. Click right there. If you haven't subscribed, please subscribe. Just hit the subscribe button. You'll get an email every time we post the video. If you don't want to do that, that's fine too. On the website, stormsurf.com, all the data that you saw presented tonight is available there. You can follow along daily and then test your knowledge when we do the video again next week. Comments are always welcome on the website. We try to keep up with it. If you have questions about weather or whatever, we'd be happy to answer them. And then also, we put a banner at the top of the website when you do the video with links to it, so you can get the link there. All right, so that's it for this week. We'll do it again next week, same time, same channel. Thanks for watching.